All right, so next we're going to look at the last part of our practice final. And it's new. There's not much to these. They're logarithms. So we're going to look at the definition of a logarithm. We're going to learn how those logarithms work. And then we're going to use that definition to solve some questions that involve logarithms. And what a logarithm is a logarithm allows you to show a big change as a small number. And a good example of that is an earthquake. When we look at the Richter scale, when we look at the magnitude on the Richter scale, the difference between a magnitude 5 and a magnitude 6 on a Richter scale is 10 times. So a logarithm lets you show a small change as a really big change. So when you go from one number to the other, you're not just going by 1, you're going by a factor of 10. pH is another example of a logarithm. Hurricanes are measured on a logarithm scale as well, and same with tornadoes. So a small change is really a big change. So it seems like when you go from a 5 to a 6 on a Richter scale, that really wouldn't be that much, but it's 10 times as powerful. So we first need our definition of a logarithm. I'll write up the definition, and I'll go ahead and give you a page number to reference as well. And our definition is on page 463. And the definition is this: y equals log base a of x. That's going to be equivalent to x equals a to the y power. So we take these logarithms and we transform them into an exponential so that we can then solve them. Because we can solve an exponential a lot easier than we can solve a logarithm. So let's look in our textbook at a few of these where we switch back and forth between a logarithm and an exponential. And then we'll talk about some properties of these logarithms. So we're now going to look at some examples on page 473. And if you don't have your textbook with you, that's fine. We're just going to talk about how to convert these. So we're going to convert these from either an exponential to a logarithm or a logarithm to an exponential. We'll do some conversion ones, and then we'll look at how to solve some of them, and then we'll look at those 3 questions on our practice final. So we're going to look at question 11. And we want to convert this to a logarithm. Now what we need to find is we need to figure out which piece is the a, which piece is the x, and which piece is the y. So right now it's in an exponential. So this x matches up to the 81. So 81 is going to be your x. The a is going to be the 3. That's your base. And that 4, well, that's your y. So we identify it based upon if it's a logarithm or an exponential, and then we look at the pieces and we label the pieces. Now we're just going to convert this to a logarithm. So as a logarithm, we need our y first, right? Because y is first. So as a logarithm, y goes first. And what did we determine the y was? That was 4 equals log. And that number below is the base. And what's my base? My base is a 3. And then what's my x? X then was 81. So the log base 3 of 81 is 4. We're just learning how to convert them. We're not solving any of these yet. We're just seeing how logarithms work, how we can transform them back and forth. So question 12 is very, very similar. Question 12 is 2 to the 5th power equals 32. So let's identify our parts first. So the number by itself is the x. 2 is your base, so that's your A. And the 5 is the y. And what does that look like when we convert it? Well, when we convert it, what do we need? When we look at our formula, the y is first. So what was our y? Our y was 5. Then we need our log. And what's the base of our log? Base of the exponent, which is 2. And what is our x value? 32. So we transformed that exponential to a logarithm. Now let's look at transforming a logarithm to an exponential. So we're going to repeat the process, but we'll work it backwards for question 15. Question 15 is log base 6 of 36 equals 2. Okay, so let's look at our logarithm up here. So the 2 is by itself. So the 2 is going to be the y. The number down below is your base, and that is your A. And then the 36, that's your x. Is everyone okay with how I labeled? See how they match up to our logarithm formula. Y is on the end, so that's your 2. The number down below, that's your A, that's your base. The number inside is your x. If I convert that to an exponential, what is it going to look like? Well, the exponential's here, and we need our x. What's our x? Our x is 36. What's our base? Base is the A. That goes there. So that's your 6. And what's your power? Your y value? That's your 2. Make sure we know how to convert these. Let's look at question 16 next. We just did 15. Let's convert 16, and then we'll learn how these actually work. So question 16 is the log base 5 of 5 is 1. So again, we identify our pieces. So the y is the number on the end. The A is the number down below, the base. And the 5 would be the x. We'll go up to our formula. And what does our formula look like? Well, we have to go up a little bit here. But here's the formula that we want. We want to convert it to that. So how does it convert down? Well, what is our x from our formula? Our x is going to be that 5. So that's going to be a 5. What's our A? A is 5 as well. And what is the x? Where it goes to? X was now, or sorry, we've got the x here. Okay. We've got our base of 5. And what's our y? Y is 1. And we know these are true because we know that 6 squared is what from the previous one? 6 squared is 36, right? Okay. 5 to the first power. What is 5 to the first power? 5. Now we're going to learn how to apply these to equations that we're going to be solving. So we'll begin with question 19. I'm going to go ahead and write our formula up so we know how to convert them. So we have that for reference here. The logarithm transfers to an exponential or vice versa. Whichever one is easier to use. Most of the time we'll turn it into an exponential. So we're going to look at question 19. Question 19 is x equals log base 5 of 1 over 625. So this is what we've got. Now, let's go ahead and label it so we know what goes where. And I know it's confusing because sometimes the variables are labeled differently, but the number inside the logarithm, that is your x. The number down below is your base, that is your a, and the number by itself, that is your y. Is everyone okay with how I labeled it? Now we're going to transform this so we can actually solve it. So let's go ahead now and try to transform. Look at your formula and look at where the pieces go. X. What was our x? We labeled x as 1 over 625. What is that going to equal? Well, that's going to equal a, which is 5, and y, which is x. Now, we can solve this. We need to solve this equation here. Now, how exponentials work, and we covered these a little bit last time, was on these exponentials, we need to either get the bases the same or the exponents the same. That's going to let us get the other missing component. So we need to make sure that these have the same base. What do we know about 625? Well, we need to make it a power of 5. So we know then that 625 is 5 to the 4th. It's all about powers, right? Because 5 to the 4th, you want to check, you can use your calculator. 5 to the 4th power is what? 625. Now, how does it work with it being a fraction? We can then use our negative exponent rule, right? Because this fraction, we know then becomes 5 to the negative 4th power, because we flipped it over. So that changed your exponent to a negative, and we know that 625 is 5 to the 4th. And what is that going to equal? 5 to the x power. Now, what do we know? We know that those bases, the 5s, these are the what? Same. So if the bases are the same, then what do we know about the exponents? The exponents must also be the same. So then what would our answer be? It would simply be x equals negative 4. Right? Because these bases have to be the same. If the bases are the same, the exponents must be the same. Let's try another one. Very similar, same type of question, 20. So question 20 is x equals log base 3 of 1 over 81. Just make sure I wrote it down right. Yep, everything looks right there. Okay, so first thing we do is we label our components. So that x is going to be labeled as the y. That 3 is down below. That's your base of a. And that 1 over 81, that's your x. So what does that transform into? Let's use our formula. X, what was our x? X was 1 over 81 again. And that's going to equal a, which is 3. Y, which is what? X. Now, we again need to come up with the same bases. So what do we know? We want a base 3. Well, 3 to what power is 81? because we have to have the same bases. So 3 to what power is 81? Well, 3 squared is 9. 3 cubed is 27, right? 3 to the 4th power would be what? 81. So that's what we want. So we know then that 3 to the 4th power is 81. We need to flip this fraction over. So that's going to make it 3 to the negative 4th equals 3x. Or sorry, 3 to the x power. And what do we know? We know the bases, the numbers below, are the same. So then the exponents must be the same. So now we have the same answer, which is x to the negative 4th power. So we transform them into an exponential, and then we solve that exponential. Let's try another one. Let's look at question 22. Similar process again, transforming a logarithm into an exponential. Once we finish this one, then we'll look at questions on that practice exam. So we need to solve now, and this one has the x in a different place. We need to solve log base x of 27 over 64 to equal 3. We've done several of these already where we convert them. Label the pieces. Okay, the number on the end, that is your y. So the number by itself is the y. The number down below, or the variable in this case, is your a. And then the number inside your logarithm, that is your x. When we convert that, what does that convert into? When we convert that, we need x, and what's our x? Our x in this case is 27 over 64. That's going to equal a, which is x. And then what's our power? Our power is 3. Now we can solve it out. Okay, this one's a little bit different because we want to make sure that the exponents are the same. If the exponents are the same, then the bases must be the same. So we need to rewrite this as a cube. What do we know about 27? Well, 27 is 3 cubed, and 64 is 4 cubed, right? Okay. So now what do we know about our fraction? Well, we know that 27 over 64 is the same as 3 over 4 to the 3rd power. Why did I do that? Because my exponent, the number on the top, is a 3. So we need to make sure my base is also a 3. Or not a 3, but the other side's a 3 as well. So both exponents are 3. That way the bases can be found. So what does this rewrite into then? Well, this rewrites as 3 to the 4th, or sorry, 3 over 4 to the 3rd power equals x cubed. And that's what we wanted, because now we know that the that the exponents are the same, right? They're both 3's. And if the exponents are the same, then the bases must be the same as well. So that gives you x equals now what? X equals now 3/4. Let's now try and look at these problems, the last 3 on our practice final. Let's go back and look at the last 3 questions on our practice final. And then once we're finished with these, we'll have time to go back and look at more questions on the practice final if we need to. So we're now going to look at question 38. And on these, I always like to write up our formula. Whenever we have a logarithm, we need to use this formula because we're going to have to convert it. So 38, what do we have? We have log base 4 of x equals 3. And we can't solve that logarithm very easily. So we're going to go ahead and transform this to an exponential. So what do we know? Well, we know that x, sorry, that not that x, that 3, what is that 3? 3 is the y. Okay, the x is x again. And the 4 here is the a. So if I was going to transform that, what would that transform into? This one's very easy to solve. That would transform then into, okay, x is x. So that's x equals. Our base is 4. Our exponent is what? The y, and that is 3. This one's actually easier than the others that we just did because all we need now is 4 cubed. And what's 4 cubed? 4 cubed is 64. So what's our answer? X equals 64. The ones I picked are pretty easy to work through. Question 39. Question 39 is the log base 4 of the square root of 4 to the 10th power equals x. And we need to first get rid of that square root. And we can't just square it because we don't want to do that. We want to figure out how we can break this down. Well, whenever we look at a square root is a half power. So we can rewrite our square root as a half power. So when I look at the square root of 4 to the 10th power, I can rewrite that as 4 to the 10th power with a half outside, because square roots can be turned into a half power. And now we know we've got our exponents here, outside and inside, and what do? They multiply together, and what's half of 10? Well, half of 10 is 4. Or sorry, half of 10 is 5. So we need a 4 to the 5th power. So we can now rewrite this as log base 4 of 4 to the 5th power equals x here. Is everyone okay with that? So we took our square root. Whenever you have a square root, you can rewrite that square root as a half power. And so that just halves that 10, and that makes it a 5. Now we can convert it, and we should have no trouble solving it out. And there's other ways of working these out also, using some of the rules of logarithms. But we're just going to try to work with it by conversion. So what do we know? Let's go back up and look at our formula again if we need to. I always like to look at it so I don't make a mistake. So this x is going to be the y because it's on the end. That 4 is the a. And that x is going to be 4 to the 5th. Now we should be able to convert it to a logarithm and solve it. So when I convert this to a logarithm, look at your formula. We need x, and what is x? Well, x is 4 to the 5th power. So there's that piece. We need our a, which is what? A, which is 4. And what's our y? X. So what do we know now? Are the bases the same? Yeah. So this one, there's nothing really else to do. So that means your x is going to be what? 5. There's other techniques that you could use. You could use properties of logarithms, which I think is what I use in the answer key. But this is another way of doing it. Just convert it to an exponential and solve it. Well, let's look at 40. Question 40 is log base 7 of 1 over 49 equals x. So we can either work with that 1 over 49 now, or we can work with it later. I'm going to go ahead and work with it now. This is a 7 down below in our base. So what do we know about 49? Well, we know that 49 is what? 7 squared. And that means that 1 over 49 is then what? 7, yep, to the negative second power. It's a fraction. So we can rewrite this now as the log base 7 of 7 to the negative second power. That equals x. Transform it, and we're done. So this on the end is your y. The number inside the logarithm, the whole piece, this whole part right here, that is your x, and the number down below, that's your a. Remember our formula? Our formula is right here. So we've already got it labeled. We just need to transform it. So what does that transform into? Well, we need our x. And x was 7 to the negative second power. That's going to equal a, which is 7. Y, which is x. So what do we know x must now be? X must now be what? Just by looking at it, the bases are the same, so x has to be a negative 2. Are those kind of making sense how to convert them? We do a lot of them. Hopefully, when you look at the practice exam again, practice final, and you do the take-home final, hopefully you'll see how they match up. Now, when you take your final, there's no hidden questions. If it's on the take-home final, it's also on the practice final, and it'll also be on your real final. All I'm going to do is cut it down to 30 questions. So if you know how to do the take-home final and the practice final, you will have absolutely no problem with the real final. I'm not changing much else. I'm not changing the directions. The word problems are going to be very, very similar, just different numbers in a different order. But of these 40 questions, I'm going to cut it down to 30. So I'm going to remove 10 of them, change the numbers, change the order, and that's going to be your final exam. So you should be well prepared for that final. Students generally do better on the final than any other exam because we spend a lot of time going over the questions, how to set them up, and a lot of them are easier than the questions out of chapter 1 and 2. So they're much simpler questions. I try to pick questions that didn't take a long time to go through. Now, do we have any specific problems to look at on our practice final? If we can't find some, then I'll pick out some. I would like for us to to stay till at least hopefully 9 o'clock. Okay, we got plenty of questions we can work through, so we can hopefully find enough to keep us here till at least 9. Are there any in particular that you'd like me to look at? Oh, go ahead.
Can we do 1 out of either 32 or 34?
Okay, one out of yep, out of one of those, the systems. Yep. How about we'll do 2 of them. How about we look at 32 and 34? So we'll look at 32 and 34. Those are the systems. What other ones? Sure, we can look at question number 11. I want to add question number, a couple of them I think we need to go over again. Let's look at question 5, because that's a circle. Students sometimes struggle with that one. Question 13, because that's how to graph a parabola squaring function. And I can add 15 just to make sure we know how to do that one. Any others to look at? Anything else? Is that going to take care of most of those? And we can add more once we get finished. So if we've got some time left, we'll work out a couple more. Okay, so let's start with question 5. I picked question 5 because it's talking about a circle. And circles came out of 2, 2, but we need to make sure we remember how to complete the square. So what we've got, and this is going to be a circle question, is we've got x squared plus y squared plus 16x plus 12y, and I'm going to go ahead and move that to 11 over. Because you always want to make sure on these circles that all the variables are on the left and just that number's on the right. So I'll move that to 11 over at the very beginning. I didn't want to write it again. Now, what do we need to do? We need to find the center and the radius so we can get the center radius form of this circle, if it is a circle. It may or may not be. So how do we do that? We have to complete the square. So we look at the x part. And the x part is x squared plus 16x. And how do we complete that square? Well, remember, what do? Half and square, right? For circles, half and square. So what is half of 16? Okay, half of 16 is an 8. So that's going to come down as an x plus 8 quantity squared. And what's going to have to be added in? Well, we add in 64. Why do we add in 64? Because 64 is 8 squared. Half and square. On circles, half and square. Now we do the same process on the y part. And what do we have on the y part? We have y squared plus 12y. Half and square. So what's half of 12? Half of 12 is 6. So that comes down as y plus 6. Now, what do we have to add in to make it factor? What's going to go in the blanket? Does anyone know? Yep, 36. Okay, and why is that 36 there? Because that 36 is 6 squared. Now, what are we going to do next? We're going to rewrite it. We had to add 64, and we had to add 36 to make it factor. Whatever we add to one side to preserve equality, we have to add to the other. So let's rewrite this now as x plus 8 quantity squared plus y plus 6 quantity squared, and that's going to equal a minus 211. We're going to have to add 64 to that and add 36 to that as well. And then when we add them up, we've got a minus 211. We're going to add to that 64 and add on that 36. That makes it a minus 111. And this is not a circle. Why is this one not a circle? Does anyone remember why it's not a circle? You may want to go back and look at circles a little bit more. But why is this one not a circle? It's not a circle because it's negative. So since it's not a circle, the graph is non-existent. So this is not a circle, and the graph is non-existent. So that's what I'd be wanting for the answer there. So it's not a circle, and that graph is non-existent. Why is it not a circle? Because that when we're to that last step, when it's in the center radius form, that's your r squared, and you can't take the square root of a negative number. When you do that, it becomes imaginary, right? And we can't graph a circle with an imaginary radius. So that's why this is not a circle. So you complete the square on the x part and the y part. If that would have been a positive 111, it would be a circle. And then we'd be able to get our center and our radius. But it's a negative, so that means it is not a circle. And that, again, is out of 2, 2. So if you struggle with that one a little bit and remembering what happened, go back and look at 2, 2. Question 11. Question 11 is, I think, one of the easiest questions. Do what now?
I said, oh, the never mind.
Yeah. Question 11 is very, very easy. All you have to do is plug the number in. Yeah, it looks complicated, and students struggle with it because they try and plug it in all the rows. And it only goes into one of them. This, again, is a piecewise defined function, but I'm glad you asked about it because this is one of the questions that is very easy, but students make a mistake because they forget what to do. A lot of times, students try to plug that 6 into all the rows. Does it go into all of the rows? No, remember, it only goes into the row where it fits. So let's talk about what each of these are. The first row is for numbers less than or equal to 0. Okay, so the first row is for numbers that are less than or equal to 0. The second row right here, that is for numbers between 0 and 5. And the last row is for numbers that are 5 or larger. And this is going to be row 1 here, 2, and 3. So if I wanted to find f of 6, is that 6? Is that less than 0? No. Is that 6 between 0 and 5? No. Is 6 bigger than 5? Yes. So which row would it fall under? 6 is bigger than 5, so it falls under row number 3. And there's not much on row number 3. Row number 3 is x, so f of 6 would simply be what? F of 6 would simply be 6. Try to find a different one. Let's try to find f of 2. Same function. Let's find f of 2. Well, where would 2 fall? Is 2 less than 0? No. Is 2 between 0 and 5? Yes. So that means we're going to use row what? Row number 2. And what do we use for row number 2? 3 minus 5x. So that's 3 minus 5 times your 2, which is then a negative 7. So do you see? All you need to do is plug it into one of those. Figure out which row it falls in and plug it in. Do not plug into all 3 of them. All you need to do is figure out which row it goes into, plug it in, find your value. This is a problem that students look at and think it's way more complicated than what it really is. This is basically I'll look at it and write down the answer type of problem because there's not much to do. As long as you can see which row it falls under, then you can very, very easily finish it. Question 13. Question 13 is one that I picked. And I've seen students make mistakes on question 13 a lot. It's another very easy problem to work out. And I want you to graph this for 13. I want you to graph f of x equals 2x quantity squared. So what we need to do is we need to get rid of our parentheses. Because remember, parentheses have to be done first. So I'm going to go ahead and distribute that square through. And we know then that 2 squared is 4. And x squared is x squared. So you see how I squared that 2 in front because that square has to be distributed through. That's where students make a mistake, is they forget to square that 2. Now, we want to graph this. So when we want to graph this, we need to find the correct picture. What operation is being done to the x? Well, it's being squared, right? And you can use the back cover of your textbook if you want to. We need to find the correct graph. Okay? It's squared, so we know our graph looks like a U, doesn't it? So our graph needs to look like that. Why is that? Because it's squared. So over to the side, I'm just going to do a quick sketch, and it needs to kind of resemble that. Where do we start at? Well, we're not moving it up or down because there's no number on the end. There's no number inside the parentheses with that x now. So where do we start at? We start at 0, 0. If there had been a 5 on the end, where would you start at? 0, 5, right? Remember, because that would control it up or down. And if there's a number inside here, that would be left and right. But that 4, what does that 4 do? That 4 is 4 over 1. So you've got to go up 4 and then over 1. So let's see where we're going to start at. We're going to start right here at 0, 0. So that's what we've got. We're going to start right here. Now, what are we going to do from the 0, 0? Well, that number in front is a 4, and it's like your slope. It's not a slope because slopes are for linear lines, but we can use the same concept. So we've got to go up 4 and over 1. So up 4 over 1, make our dot, and what does it need to look like? That. So we've got this half drawn out. How do we get the other side? Okay, how do we get the other side? Well, we do the opposite. So we have to go up 4, we have to go back 1. You know, my graph is off a bit because I don't have a graph paper here. So I had to put the dot there. And now when I curve them, we know it needs to look like a U. So there it is. There is your graph. Okay, so make sure that you square that 2 first. You'll start at 0, 0, and it needs to look like a U. $15. This is another one that I picked. It's very simple, but students make a mistake with it. So they give you on 15, they give you this graph with these points. And they're labeled negative 2, 2, and then 2, negative 2 down here. And the graph looks like this. And this is f of x. So they say there's your original graph. Now what we want is we want y equals 2 f of x. Now what is that 2 in front going to do? Well, that 2 in front is going to make it twice as tall. If it was a 3 in front, it would make it 3 times as tall. If it was a half in front, it would make it half as big. Okay, so that 2 in front, what that's going to do is that's just going to take your graph and pull it vertically. Now, we're not sliding it left or right any. We're not moving it up or down. We're just pulling it apart. And so when I regraph it, what's that going to do? Well, that's going to make this twice as tall. So we're still back here at negative 2, but instead of it being at 2, we've got to double that 2, and that makes it 4. So that's now at negative 2, positive 4. And the same thing down below. Okay, we're going to double it in size, make it twice as tall. So our second point is over here at 2, but down instead of 2, it's down 4. And now when we connect them together, look at what happened to my picture. It's twice as tall, right? That's all we did. So that 2 in front, all it does is make it twice as big. So instead of it being at 2 on the y-axis, it's up here at 4. And instead of it being down 2 units, it's down what? 4 units. So do you see what I did there? The 2 in front doubles the size of it. That's all we did. We just made it twice as tall. So don't miss that one. If it was a 3 in front of it, what would you do? If it was a 3 in front, 2 times 3 would be 6, and it would be up here and way down here. So that's all you need to do is make it twice as tall. Now we're going to end with the systems of equations again. So let's look now at our system. And we can add on 33 if we need to. We'll start with 32 and 33. 32 and 34. And if we need to, we can add 33 in as well. So we want to solve this. What we want to do is we want to get those numbers to be the same for one of the variables, so that when we add them together, a variable goes away and we get it down to one variable that we can then solve. Now, when we look at the numbers, we can either work with the y's, which are 9 and 10, or the x's, which is 7 and 1. The x's are going to be easier to work with. Now, we want to make sure that we can get rid of the x. So what we can do is we need to take this top row, and I'm going to take the top row, and I'm going to multiply it by a negative 7. The reason why I multiply it by a negative 7 is the x's will cancel out in the next step. So I'm going to take that top row, and I'm going to multiply it by a negative 7. And that makes it then a minus 7x and a minus 63y. And we need a negative 36 times a negative 7. That makes it a 252, and it's positive. You always keep one of them the same, so the bottom row is going to stay the same. So I took that top row and I multiplied it all by negative 7. Now, why did I do that? Because when I look at it now, look at my two equations written on top of each other. If I were to add down, what would happen to my x's? If I were to look down here, those x's would cancel out, wouldn't they? So if I do that and I add down, what does that now leave me with? Well, the x's are gone, right? Because a positive 7x and a negative 7x, they cancel each other out. What about the y's? Well, we've got a negative 63 and a positive 10. That leaves you with a minus 53. Y. And on the right-hand side, we've got 252 minus 40. That leaves you with 212. Now we're down to one variable. So we can divide by that negative 53. And that gives us part of our answer. And 212 divided by 53, it's a negative, so it stays negative. And part of our answer is a negative 4. So do you see how I did that? So you want to eliminate one of the variables so you can add down and solve the other one. Now, when we write our answer, we need to get the x and the y component. Right now, we only have the y part. How do we get the x part? Well, if we take our y and we plug it back in. Doesn't matter where you plug it back into. I'm going to plug it right back into the second equation because it's easy to work with. And we're going to plug in our y. And we know y is negative 4. So that's going to then give you 7x plus 10 times a negative 4 equals a negative 40. And that's then 7x minus 40 equals minus 40. Add that 40 over. So that tells me 7x equals 0. Divide by your 7. And we now know that x must be 0. So what is the actual answer as an ordered pair? Ordered pairs, remember, go x, y. So that's going to be 0, comma, negative 4. Does that make a little more sense? So you want to get rid of one of the variables. Use the one that has the smaller numbers. And if you want to, you can go back and watch the video from last week as well, because we did a lot of these last week. I think we did 33 last week as well. You can go back and look at those if you need to. Question 34. We have a minus 7x minus 6y equals a minus 13. And we've got a minus 3x, a plus 3y equals a negative 39. So I'm going to work this one out a little bit slower here. What's our goal? Okay, our goal is to get rid of one of the variables. And which one looks like it's got easier numbers to work with? Well, the y, because the y has that 6 and 3. So I think we can make them both 6 then. So let's take our second row and let's multiply it by 2. So take your second row and multiply all the numbers by 2, and then rewrite it. So keep the top row the same. You want to try to keep one of the rows the same. In some cases, when they're more complicated, which I didn't give you any really complicated ones, but if they were more complicated, you may have to change both. But in this case, we just have to change one of them. So we're going to multiply by 2 all the numbers here. So that gives you a minus 6x. 2 times a positive 3 makes it a positive 6y. And then we need a negative 39 times 2. That should be a negative 78, isn't it? Yep, negative 78. Why did I multiply it by 2? Well, when I multiplied it by 2, look at your y's now. One's a positive 6 and one's a negative 6, so they're going to go away. Okay, they cancel each other out. When I add down, what do we have? Negative 7 and negative 6 makes it a negative 13x. The y's here, they cancel. And what about on the other side? Well, the other side, we've got 78 and 13, both negative. So they go together to give you a negative 91. Finish it by dividing by that negative 13. And that leaves you then with x equaling negative and negative makes it a positive 7. Then what do? We plug it back in. It doesn't matter where you plug it back into. You can plug it into any of the equations. We didn't modify the top one, so I'm just going to plug it back into here. So we'll just plug that back into the top. And we're going to plug in now x equals 7. And that leaves you then with minus 7 times 7 minus 6y. We don't know the y, we're going to find that. Equals minus 13. So that's a minus 49 minus 6y equals a minus 13. We'll go ahead and add that 49 over. And negative 6y equals now 36. Divide by your negative 6. And that leaves you with y equaling negative 6, it looks like. Ordered pair, xy. What's our ordered pair going to look like? 7, comma, negative 6. Are they kind of making sense how they're done? Do we need to look at another one? Are we good, you think? Okay. I think that pretty much takes care of everything. And again, you can go back and look at the videos from last week too. Just look back in your email or look back at the announcements. We did a lot of these last week. We did a lot of logarithms today. I think we've covered all the material that we needed to cover. Our final is going to be next week. So let's just make sure we go over one more time what's going to happen next week. Just so everyone knows, next week is the final. So next week is going to be our final exam. If something happens and you cannot make it to the final, try to be here to the final. But if something happens out of your control, let me know as soon as possible so we can find a time for you to make up this final. Okay? But don't just not show up, because the final's worth a lot of points, and if you don't show up, it's going to drop you at least a letter grade. So make sure that you're here to take your final. If something happens, I know sometimes things happen. Maybe the car doesn't start. Maybe you don't feel well, something like that. Let me know, and I can have you take it on Thursday or Friday if you absolutely have to. But try to be here. Now, next week is our final exam, and all the homework needs to be turned in next week. So if you're missing assignments, make sure all of it gets turned in next week. So all the homework is due next week with the packet. And just so you know, that packet, you work out that practice final. As long as I see that you attempted the questions, you get that, I believe I put on here, 20 points. Okay, so as long as you work out that practice final, you get 20 points. The take-home one, though, is for a grade. That is basically your homework for next week. Hope you might have already started on it, but if you haven't, you'll want to start that as soon as possible, and that's going to be graded. So that's 100 points. That's a regular exam. Then we're going to come to class, and we're going to take our final. Now, it is worth 300 points, but students do very well in the final. Hands down, better than the other exams. As long as you do that practice final, take-home final, you're going to come to class very confident, and you'll do very, very well on that final exam. What can you have on that final exam? Okay, for the final, you can have a page of notes, or note cards, and that page of notes can be front and back. And you can also, if you need to, use the back cover of your textbook for the graphs. So if you want to look up a square function or a cube function, you can use the back cover of your textbook. Make sure you bring your own calculator. I'll have some, but the calculator I may give you may not be the same as what you're used to. So try to bring your own calculator that you're comfortable with. Nothing's more difficult to come into class for an exam where you're already worried about things, to use a calculator you're not familiar with. So please try to bring the calculator you're used to using. And I think that's it, because you can bring your calculator. You can bring your own scratch paper if you want to. Otherwise, I've got some that I'll give you. But that's going to be what's going to happen next week. And we might review for a few minutes before our final. But if you have questions, I'm here all day. So if you want to come in a half hour early or an hour early, I'm here, and I can help answer those questions. So that's what we're going to do next week. And if everyone had a good semester, and I'll see everyone next week for the final exam. The books are due when